This lesson is on right triangle trigonometry, so we're going to do some basic review, and then we're also going to look at how we can use our special right triangles to evaluate cosine of 30, 60, and 90, or sine of 30, 60, 90, or tangent of 30, 60, 90, without using a calculator. So here, let's go ahead and review our sine, cosine, and tangent trig functions. So remember, sine of theta, let's call this theta, sine of theta is equal to the ratio of a right triangle's opposite side to its hypotenuse. So we have the opposite side here, which is 8, but we do not have the hypotenuse. So we're going to go ahead and solve for that using the Pythagorean theorem. Remember, Pythagorean theorem is c squared equals a squared plus b squared, where c is your hypotenuse, that's opposite your right angle. So c squared is equal to 8 squared plus 10 squared. So that gives us c squared is equal to 64 plus 100. C squared is equal to 164, or c is equal to the square root of 164. So the sine of theta is equal to 8 over the square root of 164. And we should really break that down if possible. So the square root of 164, if we break that into primes, we're going to go ahead and simplify this radical. So if we break that into primes, we have 2 times 82, and there's a prime. 82 is 2 times 41, and these are both primes. So when we are simplifying a square root, we're looking for pairs or perfect squares. So we have a pair of 2's. So this is equivalent to 8 over 2 times the square root of 41. And you want to go ahead and get that radical out of the denominator. So I'm going to start by dividing both by 2, which gives me 4 over the square root of 41. And then to rationalize the denominator, we want to multiply by square root of 41 over square root of 41. That's okay to do because that's the equivalent of multiplying by 1. And square root of 41 times the square root of 41 is just 41. So we have 4 square root of 41 over 41. So that is sine of theta. Tangent of theta, remember tangent is equal to the ratio of the opposite side of our right triangle to the adjacent side in regards to this angle. So opposite theta is 8, and adjacent, which means next to theta, is 10. So we can say the tangent of theta is equal to 8 over 10. So now let's go to this triangle. Let's go ahead and solve for this side again for the hypotenuse using our Pythagorean theorem. C squared is equal to 6 squared plus 10 squared. C squared is equal to 36 plus 100. So that gives us C is equal to the square root of 136. So this one we're going to go ahead and evaluate with a calculator. So that's square root of 136, which gives us 11.66. So we can say the sine of theta is equal to opposite over hypotenuse. Cosine of theta, remember, is equal to adjacent over hypotenuse. And tangent of theta is equal to opposite over adjacent, so 6 over 10. Okay, so that was just some quick trig review, right triangle trig review. So now we want to look at our special right triangles. So our special right triangles are 30, 60, 90, and 45, 45, 90. But I want to go ahead and show you how these are derived. So let's take an equilateral triangle with sides of length 2. So if you have an equilateral triangle, you know that all the angles are the same. And all the angles of a triangle add up to 180. So we know that each of these angles is 60. So I'm going to divide this triangle. I'm going to bisect this angle here, which means I'm going to cut it in half. And since it is an equilateral triangle, we know that it's going to bisect this side. So we have a side of 1 here. That's still 2. I'm going to go ahead and just have the 1 here. And this angle here is 30. Okay, so you can see now we have a 30, 60, 90 triangle. We just need to know this side. So I'm going to go ahead and grab a right triangle here. And so again, there's our 90-degree angle. There's our 60-degree angle. And there's our 30-degree angle. We know that side's 1 and that side's 2. So I'm going to use the Pythagorean theorem to figure out the side opposite your 60-degree angle. So 2 squared is equal to 1 squared plus the side we're looking for squared. So that's 4 is equal to 1 plus x squared. Subtract 1 from both sides. 3 equals x squared. X is equal to the square root of 3. So this is our special right triangle. We're going to use this a lot for right triangle trigonometry. So you'll use this in this course, but you'll also use it in a pre-calculus course and really any math class you take past this one, you know, that like calculus or a course such as that. So, so there's our 30, 60, 90. Now let's go ahead and derive our 45, 45, 90. So to do that, we're going to take a square and we're going to draw a diagonal. So since we know, we'll just pretend that hits the corner there. So we know that a square has equal sides. So we're going to draw a square with sides of length 1. So there's our right angle. We know that since it's a square, the diagonals bisect these angles. So that gives us 45 degrees and 45 degrees. So now we just need to know the hypotenuse. So again, Pythagorean theorem, c squared equals 1 squared plus 1 squared. So c is equal to the square root of 2. All right, so again, we are going to use these to solve for sine, cosine, and tangent of 30, 60, 90, or 45. So let's look at the sine of 30 degrees, and we'll evaluate the cosine of 30 degrees. So again, let's go ahead and have our right triangles ready to go. So we know we're going to be using our 30, 60, 90 triangle to help us solve. So I purposefully drew this so that the 60 was situated in a different place than it was on this triangle. So you see on this triangle we had the 30-degree angle here. So opposite the 30 is 1, opposite the 60 is square root of 3. So no matter which way your triangle is situated, opposite the 60 is square root of 3, opposite the 30 is 1. So the sine of 30, so I look at 30, there's my angle of interest. Sine of 30 is equal to opposite over hypotenuse. So sine of 30 is equal to 1/2. Cosine of 30 is equal to adjacent, the ratio of the adjacent side to the hypotenuse, so that's square root of 3 over 2. Tangent of 30 is equal to opposite over adjacent, so 1 over the square root of 3. I'm going to go ahead and rationalize the denominator because that's just good practice. So I'm multiplying by square root of 3 over square root of 3 because that's the equivalent of multiplying by 1. So that gives us square root of 3 over 3. Now let's do a couple of examples with our 45, 45, 90 triangle. So opposite 45 is 1, opposite 45 is 1, opposite the hypotenuse is square root of 2. So the sine of 45 is equal to opposite over hypotenuse. So 1 over square root of 2. When we rationalize the denominator, that gives us square root of 2 over 2. Cosine of 45 is equal to adjacent over hypotenuse, which is the same thing. So 1 over square root of 2, and we know when we rationalize the denominator we get square root of 2 over 2. And tangent of 45 is equal to opposite over adjacent